From joint pain to headaches, aspirin may be the most popular pain reliever in the world. But did you know that this unassuming drug boasts a fascinating history that dates back to ancient times? Today we're kicking off the Pharmaceutical Roots content series with a discussion about the origins of this wonder drug and how it works its magic in the body. The Pharmaceutical Roots content series from LGC Mikromol, presented in partnership with LCGC, investigates the natural origins of pharmaceutical substances and offers a deeper dive into their uses, risks, and mechanisms of action. To find out more about API and impurity reference standards from LGC, visit lgcstandards.com/Mikromol. I'm Kaylin Chiarello-Ebner, the Managing Editor of Special Projects for LCGC, and I'm here today with Dulcie Phipps, the Assistant Global Product Manager at LGC. Hey, Dulcie.
Hi, Kaylin.
How are you doing today?
I'm really good, thank you. How are you?
I'm doing well, thanks. And I'm really excited about this topic. So let's kick it off. What's the link between aspirin and plants?
So aspirin is a chemical that belongs to a group of compounds called salicylates. And the simplest of these is salicylic acid. The link between plants and aspirin is that some plants can create their own salicylic acid, and they use it as a plant hormone for communication, defense, or growth. Some examples of plants with high levels of salicylic acid that you might have heard of are those pretty little purple and yellow wild pansies, irises, or meadowsweet. And you also get thermogenic plants. These are amazing. They're plants that have the ability to heat themselves up above their surrounding temperature. And it was in the 1980s that scientists discovered a plant called Saramatum guttatum, otherwise known as the voodoo lily, that could change its temperature if salicylic acid was applied to it. The reason that this plant does this is because it produces a really stinky, rotten meat smell, which attracts flies to pollinate it. And the warmer the plant is, the more pungent it is, and so the more insects are attracted. And in terms of defense, and this is something that you could try at home, if you have a house plant or a lovely vase of flowers that's looking a little bit sad, you can give it some soluble aspirin, and the salicylic acid in the aspirin helps the plant to defend itself against bacteria and fungi.
That's really interesting. I think I'm going to try that. And I had no idea about pansies and irises. That's really very interesting. So what about the human history of it all? When did people start, first using aspirin or salicylic acid?
So aspirin has been documented in ancient Egyptian texts. There's a sort of ancient medical dictionary called the Ebers Papyrus, and it's one of the oldest known medical documents from this time. It's this beautiful 110-page scroll, which is over 20 meters long. And while obviously they didn't recommend to take aspirin tablets like what we do now, the use of willow leaves to relieve pain is recommended. Even further back are the Sumerians. They're one of the earliest known civilizations from around 4500 BC. And they lived in what is now southern Iraq, and they also used willow leaves for joint pain. And basically what both of these ancient civilizations were doing was extracting salicylic acid from plants.
That's truly amazing that thousands of years ago, people were using plants in that way. But what about modern times? Can you talk a little about how chemists make it today and how it's synthesized?
Yeah, so I think many people consider Hippocrates to be the father of modern medicine, and he did recommend extract of willow bark for fever and pain and childbirth. But it was in the 19th century that pharmacists and chemists really started playing about with salicylates. In 1853, a French chemist called Charles Gerhardt treated sodium salicylate with acetyl chloride, and this produced acetylsalicylic acid for the first time. But for whatever reason, he didn't really go any further with this. And then about 50 years later, Bayer began to market salicylic acid as aspirin. There's a little bit of controversy here about who actually synthesized and promoted this drug. So generally, it's accepted that a German chemist called Felix Hoffmann was responsible for acylating salicylic acid. But another chemist, Arthur Eichengrun, also claimed to have made it. Bayer were adamant that it was Hofmann who was the inventor, but there are researchers in Scotland who think that there's compelling evidence for Eichengreen being the synthesizer. So it's a little bit strange.
Yeah, there's a lot of competition there.
Yeah.
Um, but overall, it sounds, fairly simple to make. Is that right?
Yeah, kind of. So, if you were just interested in salicylic acid, then you could make willow tea just by getting some dried willow bark and boiling it in water for 10 minutes. I read quite a few different recipes, and most of them say that it will taste like trees. So,
Oh,
if you don't like the taste of trees, then you should add honey to it.
good tip.
Yeah, but it's also something that you might have made in school or university during your chemistry class. So, just like the people at Bayer 120 years ago, you would react salicylic acid with acetic anhydride, use a bit of heat and acid as a catalyst, and then once the reaction cools down, you should start to get white crystals, and this is your aspirin.
Wow, that's amazing, but it can't be that simple on the industrial scale, right? How does it work in large quantities?
So, it's a little bit more complicated on an industrial scale, mostly because of safety. When you have a factory that has a potential for fine particles in the air, there's a really big chance that they could catch fire, like just by a really small spark. And this can create a dust explosion. So that's one thing to try and avoid. And then you also need to consider the importance of impurities. So you probably could have tried the aspirin that you made in class, but it's not likely to be very pure. And there's potential for leftover intermediates or side products or degradants. And when you have an aspirin tablet, it's not 100% pure aspirin. There's other chemicals in there that might be to help with bioavailability or stability. And there's always a chance that these chemicals might interact. So it's really important to keep an eye on the impurities present in drugs as well.
Right, absolutely. So one thing we haven't really talked about is, how you use aspirin. It's for other conditions besides just pain relief, right?
Yes, aspirin is usually given to patients who have had a heart attack or a stroke because of how it works in the body. So, very simply, because I'm not a biologist, it inhibits the activity of enzymes that are responsible for producing certain lipids. The lipids are found all over the body and they send messages to the brain signaling pain. So, that's why aspirin works to provide pain relief. Some of these lipids are also associated with blood clotting that can cause heart attacks. So, by inhibiting these, there's less risk of death, which is always a good thing.
Right.
Along the same lines, it's thought that baby aspirin, taking one of them a day, can help prevent cardiovascular events in the first place. And there are a lot of studies suggesting that aspirin might help to lower the risk of developing cancer. And probably most relevant at the moment are there's lots of studies about treating patients who have COVID with aspirin. So there are some retrospective studies carried out in American hospitals that found that patients who were already taking a low dose of aspirin for cardiovascular disease had a 47% reduced rate of mortality and a lower risk of being placed on a ventilator. I think that this relates to the blood clotting prevention that I just mentioned.
Mhm.
There's also studies being carried out by Oxford University called Recovery, or Randomized Evaluation of COVID-19 Therapy, and they have over 36,000 participants in 178 active sites in the UK. And basically, what they're doing is trying to identify COVID treatments by repurposing safe and easily available medicines, and aspirin is one of these ones.
Wow, it's just incredible to think that something that's been used for thousands of years is still so relevant today. It's really, really interesting. So you mentioned that during the synthesis, a number of impurities can occur, and I was wondering if you could talk a little bit more about that. So are my aspirin tablets as safe as I think they are?
You definitely don't need to worry. It's what companies like Mikromol help other companies do, is make sure that your medicine is safe to take. Pharmaceutical companies have to ensure that every potential harmful impurity is below a certain level so that your drugs are safe. So in more detail, in a drug, there are two components: the drug substance, which is the active pharmaceutical ingredient, and the excipients, which are these chemicals I mentioned before that can help with bioavailability and things. Together, these form the drug product. So, if you have all these different chemicals, there's a chance they might react and form other compounds or degradation products. So, that's one thing that needs to be monitored. Another way impurities can arise is during the synthesis of the API. So, it's unlikely that the synthesis will be a one-step reaction, and not all of the reactants will react 100%. There'll be bits left over, and those are called intermediates. And then another type of process-related impurity are side products. And these are the result of reactions besides the desired reaction. There's more than 10 different impurities that can occur in aspirin manufacturing, but Mikromol have different reference standards for each one. So companies can use these to make sure that impurities are only present in the amount that's allowed. And that's why your aspirin is still safe.
Excellent. Thank you so much for speaking with me today, Dulcie. It's really been interesting to learn about the roots of aspirin and all the new applications that are still being discovered today.
Thank you. It's been lovely talking to you too.
And thanks to our audience for tuning into this episode, and be sure to check out the upcoming segments of the Pharmaceutical Roots podcast series brought to you by LGC Mikromol in partnership with LCGC. LGC is your trusted partner for pharmaceutical API and impurity reference standards. To find out more, please go to lgcstandards.com/Mikromol. Mikromol, making a positive, measurable difference.